This is Clapgate Beck. It's illustrative of the Torrent Stage. It's got these things. We'll draw them in so you can actually see them. They are in fact spurs of land. And you can see the spurs of land interlocking. This gives you your classic V shape of the Torrent Stage of a valley. The most important feature of the Torrent Stage is the river is cutting down vertically. This process is called corrasion. It's the bed load bouncing along the bottom of the river. Each collision takes a small amount off the river bed. So that's what's caused these series of interlocking spurs with the river or stream running round the spurs. If you actually look at the valley floor, the actual process can be seen in potholes. No valley floor is absolutely flat, and it does cause the water to swirl round. Swirling water with bits of grit and sand in spin round and actually drill holes into the bed of the river. These are called potholes. Waterfalls are the result of rocks of different hardnesses being thrust together or placed together. Beautiful diagram here. 3 rocks: limestone, sandstone, shale, each one of different hardnesses. This sequence is found all over the Yorkshire Dales. It's called a Yoredale sequence. It's a cyclothem. It's a repetitive sequence of rocks. This series is actually repeated 11 times and is responsible for most of the waterfalls in the Dales. You can see where the water comes over, it creates a huge plunge pool. Here it is here, coming around here, and it's actually flowing out towards us in that direction. What I'm going to do for you now is to show you the 3 different rock types. The first one is the shale, which runs around there. Remember, shale has the same composition as clay. When it decomposes, it's very easy for material like this green stuff to colonize it. The next layer is a layer of sandstone, which we'll put in here. That's your layer of sandstone. And above it, your very, very hard limestone. Let's now examine what's happening when the waterfall comes across the top of the falls, makes little impression on the very hard limestone, but is attacking the soft shale. It attacks the soft shale, or wears it away, in a number of ways. The sheer force of the water is the hydraulic action. The next way is corrasion. Over the top of the falls, sand, gravel, pebbles, even some huge boulders, like this one, have been taken over the top of the falls. This process is called corrasion. The water is also acidic, mildly acidic, but enough to dissolve some of the rocks. There is another way that this is eroded. Sometimes you can actually see the spray going onto the shale. In winter, the water actually freezes, expands, and forces the shale layers apart. So very quickly, all of this is eroded. It leaves a cave behind the waterfall. Eventually, there will be nothing here to support the rocks here, and they will crash into the pool. The result is that this waterfall will actually move backwards in this direction. This is called migration. All waterfalls migrate upstream, and as they move, they take a thin slice off the land. Imagine a river with 50, 100 waterfalls on it. Each one is taking a slice of the landscape. Because of the steep gradient of the long profile, the Torrent Stage is typified by waterfalls and rapids. These are the product of differential erosion. Soft rocks will more easily be worn away than hard rocks. Let's have a look at the diagram and see what's happening. Well, you have two kinds of rocks here. This could be your Yordales limestone. This could be your Yordales shale. Limestone hard, shale very soft. Differential erosion will take place here. The shale being soft will be easily cut back. Let's examine water coming to the edge of the waterfall, the lip, crashing down into the plunge pool. This is where you have your corrosion. This is damage to the river bed. Water will splash back onto the shale and you'll have some hydraulic action and a little bit of solution there. But eventually this area will be undercut. In time, the waterfall will lose this block. And as you can see, when that block crashes into the pool, you're going to have a new waterfall there, which will actually be higher than the waterfall there. So as the waterfall retreats, as all waterfalls do, this scenario gives you a waterfall that is actually getting higher. In the next scene, you will see a waterfall that gets lower. All rock strata does not dip in this angle. Notice the word dip. That's the dip of this layer of rock. But let's alter the layer dip by putting in a new layer. We'll take it from there. And now you can actually see this layer of very hard rock dips upstream. If you knock a block off here through the normal processes of undercutting, you can actually see the waterfall will in time become less high. It will in fact, near its deathbed, turn into a rapid and then fizzle out completely. Here I am standing on the lower falls at Aysgarth. Once again, it's part of the Yorkshire Dales Cyclothem series. But here the river is cutting back extremely rapidly. It's cutting back so rapidly that the sides of the river, the valley sides, haven't had time to erode down into the river. As a result, you can see behind me the wooded slopes are actually covered. They're vertical. This is the formation of a gorge. The fast water up there is a rapid. Rapids are the result of waterfalls migrating upstream. As the waterfall migrates upstream, its height reduces till eventually it ends up just as a fast piece of water, a ripple or a rapid. That's what we've got up there, but it's on the outside bend of the river.